Okay, experiment number 4, kinetics of acid catalyzed hydrolysis of methyl acetate. Methyl acetate means CH3CO or CH3. This is methyl acetate. Methyl acetate, acid catalyzed hydrolysis. That means one of acid will catalyze this experiment, this reaction. Hydrolysis will happen, H2O. As products, we will obtain CH3, CO, OH from this water molecule and methanol, OH. This O will get remaining H of this water. Okay, these are the products. So, this is acid catalyzed hydrolysis of methyl acetate. So, we have to know this is an ester. Ester will evaporate very easily, so we have to do this experiment inside a stoppered bottle. That's the first thing. Okay. Okay. Now, what are we going to do? We will we have provided pure methyl acetate solution in a bottle, stoppered bottle. Okay, what should we do? They have provided us the density of this methyl acetate as 0.925 kilogram per cubic meters. This is the density of this methyl acetate solution. Okay, we have HCl solution also, 1 mHCl. So, 50 ml of HCl, we will add 5 ml of this methyl acetate solution, 5 ml of methyl acetate, actually 5.00 ml, 2 decimal points. So, what will happen? Automatically this reaction will happen. Here HCl contain 50 ml HCl, it have adequate amount of water. So, reaction will start when we are mixing these two things. However, before starting this, we have to maintain the temperature of two reactants in a water bath. අයියේ මේක 20 Celsius 25 තමයි 25 degrees වලදී තමයි කරන්න ඕන. So, we have to maintain a water bath at 25 degrees Celsius. We are dealing with rate constant. Here kinetic experiment again. So, we have to maintain the temperature 25 degrees Celsius. So, we have to add ice cubes and we measure the temperature by using a thermometer, and we can adjust the temperature of this solution by, we have to use a stirrer also, glass rod or something. We have to stir this solution to get a homogeneous or unique temperature throughout the this water bath. After it's reaching to 25 degrees, we will dip our two solutions, two reactants. First one is HCl, second one is methyl acetate. Both solutions we have to put inside this water bath until they are reaching to 25 degrees Celsius. So, we have to check their temperature also by using thermometers. After they are getting 25 degrees Celsius, we can mix them. We have to, actually mixing mean we will get 5 ml of this methyl acetate solution into a graduated pipette or 5 ml pipette, and we will put it into this HCl containing stoppered bottle. We are using stoppered bottle because we are dealing with the ester methyl acetate ester, it will be evaporated. That's why we are using this stoppered bottle. However, when these two solutions are getting mixed, reaction will start. This hydrolysis will start. So this is our reaction mixture. Now we mix them. So we are adding, initially we add 5 ml of how much? 5 ml of methyl acetate. So in this situation also we have to think about the draining time. We are adding 5 ml. We are dealing with time, we using stopwatch. We have to switch on stopwatch when we are adding half of the methyl acetate solution from this pipette. If we start at initially, when the first drop is draining into this reaction HCl, what will happen? Reaction rate will be very higher, because here we add 1 drop to compare to that drop. Here HCl amount is very high, so reaction will be very higher, rate will be very higher when we adding first drop. When we adding last drop, if we add last drop, what happen? Now the reaction rate is very low, so both are errors, so we will consider middle value. So when 2.5 ml is draining, we will start stopwatch. Okay, that's how we get rid of the draining time error. However, after starting stopwatch, after 6 minutes, we will extract 5 ml of this solution. We will extract 5.00 ml of reaction mixture and we will put it into a ice containing conical flask. Here it containing ice. Why is that? We are adding this reaction mixture into ice containing conical flask. It contains ice. Ice means temperature nearly 0. So what will happen? This reaction is, optimum temperature for this reaction is 25 degrees. Room temperature is the optimum temperature for this hydrolysis reaction. So when we add this reaction mixture into this ice, what will happen? Reaction rate will be low. It will decrease. Rate will be decreased. So reaction will very slow. It will not happen. Or reaction will stop, or reaction rate will be very low. So at that time we titrate this reaction mixture with sodium hydroxide solution. Okay, now what should you know? In this reaction mixture, what are the ingredients? After that reaction, this this methyl acetate will broke into acetic acid, CH3COOH, acetic acid. This is acid, and this, when we titrate, this sodium hydroxide will react with acetic acid plus solution contain already HCl. We know that HCl is not consuming actually, it is regenerated because it is a catalyst. So this 5 ml of reaction mixture contain acetic acid and HCl both. So sodium hydroxide will react with both of HCl and acetic acid. Okay, we can read that reading after titrating. This is our titration. We add our reaction mixture 5 ml and this sodium hydroxide. We add phenolphthalein as the indicator. Okay, so here after titrating we get the end point. We will read the volume of sodium hydroxide. That means that volume contain, it indicate the it reacted with HCl and acetic acid both. However, we have to remember that HCl is always constant for every steps because HCl is a catalyst. It will be regenerate again and again, so it will not consume. So after getting this reading, after 12 minutes we will get second reading. What will happen? After 12 minutes we will extract again 5 ml from this reaction mixture. We have to use a pipette for this extraction also, and we will add into a ice containing conical flask again. After 12 minutes what will happen? What can you say? Initially in 6 minutes this reaction happened, it is initial time, so acidic concentration will be low here in first time. However, after 12 minutes what will happen? Acidic concentration will be higher than first one, because now time is gone, 12 minutes, so more amount of acetic acid will form. So acetic acid concentration will be higher in after 12 minutes. What about HCl? HCl is normal, it is same thing because it is regenerating, it is a catalyst. So after this is 6 minutes, after 18 minutes, what can you say? After 18 minutes the product acetic acid will be more than 12 minutes, because now time is 18 minutes, more time passed, so more and more acetic acid will form with the time. So acetic acid concentration will be higher here. So but HCl concentration is same thing because it is regenerating catalyst. Likewise, we can get an idea about acetic acid. Acetic acid concentration will be higher with the time. So here we have to deal with we have provided the equation T equal 2.303 divided by K log 10 base V infinity minus V naught minus 2.303 divided by K log 10 V infinity minus V naught. Likewise, this equation we have provided. What can we say? We will plot a graph with time and log 10 base V infinity minus V naught. So after plotting this graph, by its gradient we can get the K value or rate constant at 25 degrees. So what is this V infinity? V infinity mean volume of sodium hydroxide required to neutralize all the produced acetic acid, which added is 5 ml. Initially we had 5 ml of acetic acid. To neutralize the all acetic acid, we had methyl acetate. Sorry, initially we had 5 ml of methyl acetate. After some time, after time t, all of the methyl acetate will convert into acetic acid. At that time, the required sodium hydroxide volume is the V infinity. Okay, to calculate that, we can use the provided density values of methyl acetate 0.925. So using this equation, you know the stoichiometry. Okay, so you know the density of this. If you know the mole amount, calculate the mole amount of this methyl acetate, you can calculate the finally produced acetic acid concentration. So after that, you can substitute that V infinity and you read the V naught. Here VT, you will read this VT. VT mean at that 6 minute intervals. Initially Vt is 6 minutes. At that time we read this volume, it is Vt. Likewise, we have to read the 6 minute interval, we have to read the volume, that is the Vt. So likewise, you can plot a graph and you will get the K or rate constant from this graph gradient. Okay, it is first order reaction. Okay, those are the summary. You have to take care about some things. I will explain them. So we are using stoppered bottle to do this reaction because we are dealing with the ester. Ester will evaporate very easily, so we will use stoppered bottle to minimize the evaporation of esters. Okay, we have to clean these all glasswares, especially burettes and pipettes, and this stoppered bottle also. Initially tap water, next distill water, rinse. Burette and pipettes will rinse with relevant solvent. We are going to measure. Draining time, we have to take care about draining time. So when we adding methyl acetate into this reaction HCl solution, we are considering half of draining time. Imagine it is 0 when we start the stopwatch at 0. Now time passing. So we have to add extracted 5 ml of reaction mixture, we have to add into ice. Consider the draining time is 10. If the draining time is Td is 10 seconds, we have to start the draining of reaction mixture after 6 minutes. We have to start when 5.55 seconds and draining will finished after 6.05 seconds. So here this 5 second mean here draining time, half of draining time is 5 seconds. So by using this method we can get rid of the draining time error. We start the draining after 5.55 seconds, we stop 6.05. 5 seconds, there is a 5 second gap because 6.05 because it is the draining time error. So to drain at 5.55 we have to take that 5 ml before we are reaching to this time. Around 5.30 we will get 5 ml and we will keep above the conical flask, and when time is reaching 5.55 we will start the draining and it will stop at 6.05. That's the draining time error. Okay, we have to use a water bath to this reaction and we using phenolphthalein as the indicator, and we have to use a white tile every titration to observe the color change, colorless to pink color. Okay, we have to shake or we have to swirl this every solution during this experiment because we have to get a uniform temperature, uniform reaction mixture. So we have to stir this solution or shake this solution or swirl this solution very well every time. Okay, we have to use 5 ml pipettes and 50 ml pipette if they were provided. If not, we can use because initially we have to add 5 ml of methyl acetate into 50.00 ml of HCl. To measure that 50.00 we have to use the burette. Okay, we have to use a stopwatch. We are dealing with time and we have to maintain the temperature. We have to take care about the draining time, and when we are dealing with burette, as I said previously, we have to wash it tap water, next distill water. After that we have to rinse it with the relevant solution. If not, concentration will be low or dilute. It will be an error. Okay, so when we drain this solution, every time the pipette should in vertical position. Same person should control or handle this pipette because If it is slant, what will happen? There will be a resistance with these walls of the pipette. It will be a error. So you have to allow the solution drain under the gravity. So you have to keep it in vertical position. Okay. Next, we should not touch the bulb of the pipette. When we are using a bulb pipette, we don't have to, it is wrong, because if we hold the pipette from its bulb, the temperature from our body temperature will transfer into the pipette, and our solution in the pipette will expand. So it is an error also. So we don't handle pipette by touching its bulb. Okay, those things you have to remember. We are doing this experiment, this titration in a conical flask which contain ice. We using ice because of we have to stop the reaction, or we have to slow the reaction. Okay, those are the basic things you have to remember. Okay, this is the experiment 4. Next we will move on to experiment 5.